we have a buggy carrying a 5 kilogram load, and we are pulling on it with a 50 Newton force, assuming no friction. Yeah, I could have added it there. Assume no friction with ground. Okay, now we make that assumption based on wheels. When we have wheels, we have a lot less friction, so that's why that assumption is quite valid. Now, if that's the case, now along the vertical, we have forces that are balanced. We know that they are balanced because the buggy is not going to fly off or sink into the ground. What's left is only the horizontal. Now, along the horizontal, we have the 50 newtons that's unbalanced. So my net force is 50 newtons. Now, the question is, what is the net force on the green crate? That's going to require a little more work. Now, how do we find how much is the net force on the green crate? We know the net force on the buggy, and that's the net force on the buggy with all of its load on top of it. The net force on the green crate is going to be the mass of the green crate times its acceleration. That's one way of finding that net force. The other way we can think of it, what's going to cause the green crate to accelerate? What's going to cause the green crate to accelerate is the fact that there is a static friction force between the buggy and the crate. And the static friction force has to be in the forward direction to result in an acceleration of the 5 kilogram crate. Now, however, we don't have any tool to help us find that force. We don't have the coefficient of friction. We might be able to find the normal force, but we don't have the coefficient of friction to be able to find the static friction force. And even there, static friction is a little bit more complicated because knowing the coefficient is not enough. The coefficient tells us what the maximum static friction is. It does not tell us what it is. Okay, so we have to resort to this. To be able to use this, it's a lengthy problem. Not very lengthy, but a little lengthy. We have to find the acceleration. The nice thing is, the acceleration of the buggy and the crate is the same, since they are moving together. So what we do, we need to try to find their overall acceleration in the beginning. So what we do, the net force, we analyze the buggy crate situation. The buggy and crate together, their net force, we said, is 50 newtons, meaning their overall acceleration is going to be 25 kilograms, their overall mass, times 8. And I can find their acceleration. 50 newtons over 25 kilograms is 2 meters per second squared. So if we apply this here, that's the same acceleration as the green crate. So that tells me the net force on the green crate is going to be mass of the green crate, 5 kilograms, times 2 meters per second squared. So it's going to be 10 newtons. That's the net force on the green crate. Now the question, what are the forces acting on the green crate? We just mentioned one. First one is the static friction force between buggy and green crate. Okay, the other force is, let me make it in big so we can see it, the gravitational force that the Earth exerts on the green crate. And the third force is going to be the normal force that the buggy exerts on the green crate. Now, these two along the vertical are going to be balanced. The one along the horizontal is not balanced, and it's going to be equal to our net force, and that's going to be the one that causes the crate to accelerate forward. Okay, now, what are the reactions to all the forces acting on the green crate? Okay, so now, apply Newton's third law of motion. What's the reaction to all of these forces? We discussed them one at a time. We said there is a friction force that the buggy exerts on the green crate, and we said that friction force is in the forward direction. So as a reaction to that, the green crate is going to exert a friction force on the buggy, green on buggy, in the backward direction. Okay, that's one reaction. The second force we said is the Earth is pulling down on the green crate. The reaction to that is, think of the big Earth, and all the way down here at the middle of the Earth, there is a force that the green crate exerts on the Earth. A gravitational force of green crate on the Earth. That's that reaction. Now, the third force we discussed in the previous screen was a normal force that's exerted by the buggy on the green crate. The reaction to that should be a normal force that, so it's a normal force that the green crate exerts on the buggy. Okay. These are the reactions. Now, what are the forces acting on the buggy? Of course, there is the easy one, this 50 Newton force. We ignored friction with the floor, but then there is a normal force from the floor, Fn floor on buggy. There is the gravitational force, that's F Earth on buggy. There is a reaction to the normal force that the crate exerts on the buggy. Did I say it right? The buggy exerts a normal force on the green crate, so the reaction would be the green crate exerting a normal force on the buggy, and that's what we are interested in. F, normal green on buggy. And then we discussed the friction force that the buggy exerts on the green crate. So the reaction to that one is the friction force that the green crate exerts on the buggy. These are the 5 forces acting on the buggy. What are the reactions to all of these forces? Okay. Now, if this 50 newtons is exerted by someone pulling on it, the reaction is the buggy is pulling back with 50 newtons. Now, there is the normal force with the floor. The reaction to that, the buggy is pushing down on the floor with a normal force, VBF, buggy on the floor. Gravitational force, the earth pulling down on the buggy, the reaction, the buggy pulling up on the earth. So Fg gravitational, buggy on earth. So we have now 3, we have the 2 left. Now there is the green crate is exerting a friction force in the backward direction on the buggy. The reaction to that would be the friction force that the buggy exerts on the green crate. And then the green crate exerts a normal force downwards on the buggy, and the reaction to that is the buggy exerting a normal force on the green crate. You notice that all of these reactions in the subscript, they have buggy B first, and then whatever else. They are all forces exerted by the buggy because of the forces that it was subject to.